right, in this lesson, section 10.2, we're going to be talking about arc measures and their central angles or central angles that subtend to create arc measures. So first of all, let's talk about what is a central angle, and we'll talk about minor arcs, major arcs, and semicircles, which hopefully you've heard some of those terms. But I want to give you an example of what this kind of relates to. When we talk about angles being created at the center of a circle, by definition, right, their vertex, the angle is at the center of the circle. So when we're looking over here off to the left, we've got a circle here, circle A, and there's angles being created when we create like these two radius lengths. You'll notice there's an angle here that we could measure, and there's an angle out here. So that we can see that different angles related to the center of the circle are what we call central angles. As an example, maybe some of you are familiar if you've ever flown and you've seen an image similar to this. You've seen a lot of circular farm fields, and farmers use these. They use these central pivot sprinkling systems so that they can put their sprinkler there extending out to the outside. You'll notice it looks like the radius of a circle, and then it can rotate all the way around using a motor in the center so that the farmers don't have to go out and actually change their water lines. Again, we are looking at parts of a circle. So you can see their system here. They have their radius there, and it's rotating through watering parts of the circle. So as it rotates through, it creates like an angle or a section of the field that has been watered, and we can relate that angle at the center to how much of the field that has been watered. We'll talk about sector area in a later lesson, but for today we just want to talk about how to name them, the notation, and how to communicate the arcs related to their central angles. So again, the angle is at the center of the circle, and the arc is a piece of the circumference or the outside here on our circle that's related to that central angle. So notice if I'm sprinkling my field and I rotate my sprinkler here through 100 degrees, we call this the arc that it's created, or this arc that's subtended is also a 100-degree measure. So the central angle relates to that arc that it's created. So we're just going to talk about this vocabulary, how to name them, and look at a little bit of the notation. So first of all, again, a central angle there whose vertex lies at the center of the circle. Again, we name them just like we would do any other type of angle. So if I'm creating angle A right here, I would call this angle BAC. We put A in the middle because if we're moving from B to A to C, it creates that angle right there. So we would say angle, we use that little symbol, and we're talking BAC. Now, a question you might be asking is, I'm sure this is the question you're asking, is why did I choose this side of the angle and not this larger angle out here? Now, that's a great question. That's where these words minor and major are going to come in. This one that's smaller, we would call the angle that is subtending this minor arc out here, and this larger one is the one subtending the major arc on the outside. And remember that circles, their degree measures are 360 degrees, so if this piece on this right side is 100 degrees, this one out here must be 260 degrees because it has to create 360 degrees total. So that's essentially what we're talking about. So if I was going to define the measure over here for angle BAC, if I'm talking about the minor arc that's being subtended, and I'm just going to write minor so I remember that, I'm going to do 100 degrees. If I was talking about the major or the larger angle there, then it would be the 260 degrees. So we're kind of looking at both there. I'm going to erase this. All right, let's talk about a minor arc. So a minor arc that's being created, again, arc is a piece of the circumference, is an arc whose measure is less than 180 degrees. And the way that we write an arc, so remember if we're writing a line segment, we wrote like B to C, and then we put a line over the top of it. An arc has an arc over the top, so we're denoting that we're moving from point B to point C along a curved line. So the arc denotes a curved. So we would say from B to C, and we would put an arc over the top. Now, sometimes the arcs are hard to draw. But again, notation is everything. That is different than the line segment from B to C. If we were talking about a segment, that would be a straight line that moves from B to C. No, that's almost straight. If we're talking about arc B to C, it's also important that you remember that when you're moving from B to C, you always go the shortest distance possible to get from B to C, unless a third letter is given, like the major arc. So notice if I just say arc BC, like I did right here, I am implying that I'm moving the shortest distance. So this would imply that I'm talking about this minor arc right here. And again, the measure of arc BC, so measure of arc BC would be equal to 100 degrees. Now the major arc, if I want to talk about the arc that moves from B through D to C, so this major arc out here, which is greater than 180 degrees, then I want to use 3 letters. So I would say from B through D to C. Again, B and C are the endpoints, but it's stating that we are moving through D to get to C, so that denotes the major arc. Always use 3 letters when you're denoting a major arc. Otherwise, you would move the shortest distance, which would take you through a minor arc. So again, the measure of B to D to C, and we already talked about this. If I'm moving this direction, that angle measure was 260 degrees. Okay. The last one is a semicircle. So semicircles have an arc measure of 180 degrees. So probably the one that we're the most familiar with. And again, I'm going to draw one in just so that we can kind of talk about it. If I were to draw in another point here that created a diameter, and we called this E, and that's straight, then this angle measure right here, this whole thing, right, would need to be 180 degrees because it creates a diameter. And if that was thicker, maybe it would look more like one. But we would say E to C. Now, it doesn't matter if I give it a middle letter, because in this case, no matter which direction around the circle I go, that's still a semicircle. And this one, if I did the measure of EC, that would be equal to 180 degrees. Again, you're always looking for semicircles. They make it a little bit easier to identify. If I were asked what is the angle measure of E to A to B, again, if I know that this is a semicircle and this side is 100 degrees, then I know that this one would be 80 degrees. So always looking for semicircles to help you define those. Moving down, let's kind of practice using this notation. Again, this is not a super challenging concept, but just important that we understand the notation so that when we start calculating sector area and arc lengths, that we're able to use the measure of the arc to do so. So, using this circle diagram below, we're going to determine all of the indicated measure or circle parts and measures. It says be sure to use appropriate notation. If defining an arc measure, we are going to state whether this is a minor arc, major arc, or a semicircle. So the first thing I would do in looking at my circle over here is I would fill in the angle measures. That will allow you to just work off of that. So we're already given that this is 60 degrees, so remember this arc out here, right, would also be 60 degrees. You don't necessarily need to write those in, but just know that the central angle measure relates to the arc that subtends that. Remember that symbol on the inside there is 90 degrees, so we know that these guys are 90 degrees, right? And then we could fill in the other pieces. So again, we're looking for semicircles, so or diameters. So notice E to B, this right here is a straight line. We know that that has to give us 180 degrees over here. And you've already got 60 degrees right here. So that means to finish out this straight line, this guy over here would be 180 subtract 60. That would leave me with 120 degrees for angle A. Again, looking at this as a diameter and as a semicircle, you've already got 2 angles here, and again, you just need to fill in this angle right here. This is 52 degrees and this is 90 degrees, right? That's 142 degrees. Then that would leave you, if you subtract that from 180 degrees, with 38 degrees as this angle here. So filling in those angles will allow us to quickly answer the questions off to the left here. So first, the measure of arc DF, and again I'm going to use notation as I write this out. So measure of arc DF, we're denoting an arc by using the little arc symbol. That would be equal to, we come over here and again we're moving from D to F, and we're going in the shortest distance possible, so D to F. If I take 120 and I add 38 degrees right here, that gives me 158 degrees. That would be the measure. Moving over to number 2, this is an angle, so this asks us to find the measure of the central angle EAD. So again, just move along the letters as they're listed. If I'm going from E to A to D, notice that that created this central angle right here of 38 degrees. So I know that that is equal to 38 degrees. Number 3, the measure, again, of arc, this time EB. So again, I'm going to start at E and I'm going to go shortest distance until I arrive at B. Notice that one's the semicircle, so that one is 180 degrees. This one is asking us to find the arc, so what would the arc be that has an angle measure of 142 degrees? So if we're looking at this, and actually this is one we already mentioned out loud, but 142 degrees, these guys would be too much, these guys wouldn't work out there, but notice that 90 plus 52, that would be 142 degrees. So if I want to write from arc D to B, notice that's a minor arc, so I can just write D and B. That would take me there. So we would say arc DB. Oh, that's a C, so let's use a B. Again, you could write DCB, that would be fine. That would take you to the same spot. Number 5, the measure of, and again I'm going to write measure of DBF. If I'm moving from D to B to F, I'm going to add all of those together. So 60 plus 52 plus 90 should give me 202. Number 6 asks which arc would represent semicircles. We kind of already looked at this one. This would go from E to B, right? So you can write EB. That would be a semicircle. Again, if you wanted to write E to D to B, that's fine too. Or you can go around this direction and write E to F to B. Any of those are fine as long as your endpoints there on the arcs are E and B. All right, last two, looking at these. The measure of CAF subtending a major arc. So we're looking at C to A to F. So here's C to A to F. And again, it says subtending the major arc. So this guy out here is the bigger angle, and it's subtending the major arc. So we are going to add up all of those. And I'm sorry I erased them, but this one was 120 plus 38 plus 90. Which leaves us with 248 degrees there. And then lastly, the measure of arc CE. If I'm looking at C and I'm moving to E, again, I go shortest distance unless there was a third letter, so I'm going to go shortest distance here. 90 plus 38 leaves me with 128 degrees. Lastly, it just asked me to state whether they were minor or major arcs. So looking back at number 1, this is less than 180 degrees, so I would call this one a minor arc. Again, number 2, that one's an angle, so we don't need to identify that. Though that is less than 180, it would be a minor or subtend a minor arc. Number 3, this one would be a semicircle. Number 5, 202 degrees, that would be a major arc, right? That's more than 180 degrees. Same with number 7. This is a major arc, although it told us that. And number 8 would be a minor arc. So just making sure that we understand what we're looking for there. If you guys will jump down, maybe try 9, 10, 11, and 12. If you can identify those arc measures, they're giving you the central angles. And then we'll talk more about this one in the next video.